Well, here we've got a polynomial of degree 4. That means that it has 4 roots. So if you set it equal to 0 and solve for x, we'll have 4 answers. And one answer is already given. That one answer is going to be x equals 2i. Well, the way that you get an I is by taking the square root of a negative. So somebody must have taken the square root. So if I undo their work, if they took a square root, I'm going to do the opposite and square. So that means that x squared is equal to, well, 2 squared is 4, and then I squared is negative 1. So in other words, they must have had x squared equals a negative 4, and then they took the square root. Or if you move the 4 to the other side, right before they had x squared minus 4, they had, right before they had x squared equals a minus 4, they must have had x plus 4 equals a 0. That means that this is a factor of the polynomial, which means that x squared plus 4 will divide into this polynomial evenly. So the next thing to do is divide. And I just need a little more space. So divide x squared plus 4 into x to the 4th minus 3x cubed plus 9x squared minus 12x plus 20. And if the x cubed, for example, would have been missing, I would have left a space right there. So if there was one term missing, then I would just leave a space. Okay, the next thing to do is just think, what should I put right here for this happy face so that when I multiply it with x squared, I get x to the 4th. Yes, you're right. The happy face needs to be replaced with an x squared, because x squared times x squared will be x to the 4th. And then also distribute the x squared times the 4, which is going to be a positive 4x squared. So I'm going to line that up with the x squares over here, a positive 4x squared. All right, the next thing to do is subtract. So x to the 4th minus x to the 4th, they will cancel. This negative 3x cubed has nothing to combine with, so just bring it down, negative 3x cubed. And then make sure you pay attention to a negative times this is going to make it actually minus 4x squared. And 9x squared minus 4x squared is positive 5x squared. All right, that's the process. We now just repeat. So next, I need to put something which is going to be a negative 3x, so that when I distribute it to this, it gives me negative 3x cubed. And then distribute it to the 4, and that's going to be negative 12x, which I'm going to line up over here, negative 12x. And then subtract. So these will cancel. The 5x squared is just brought down. And once again, make sure you pay attention to the sign. So negative negative is actually going to make this a positive 12x squared. Together with this negative 12x squared, they're going to cancel. And then the only term that's left is this 20. So bring down the plus 20. Also keep in mind that since this is going to divide into it, that means the remainder has to be 0. So in my next step, I should get that the remainder is 0. All right, next I need a 5x squared. So that means multiply with a 5. So multiply with a positive 5. Sure enough, that's 5x squared. Distribute, that's going to be a positive 20. And then when you subtract, these are going to cancel and these are going to cancel. So the remainder equals 0, exactly as it's supposed to. Yes. All right, to find the last two solutions, I just need to do probably the quadratic formula. So I've got an x squared minus 3x plus 5. An x squared minus 3x plus 5. When does that equal 0? So using the quadratic formula, it's going to be negative of the b plus or minus the square root negative b squared minus 4 times a, which is 1, times c, which is 5, and the whole thing is divided by 2 times the a. Okay, so let's see, negative is positive 3, plus or minus, how much is inside the square root? Well, negative 3 squared is positive 9, minus 20. 9 minus 20 is negative 11. So inside the square root, there's a negative 11. And the square root of a negative is an imaginary number, so that means it's 3 plus or minus, and then I could just say the square root of a negative makes it I, square root of 11, and then divided by 2. And then we also got that x equals 2i, because that was given. And then complex roots always come in conjugates, so there's always the plus or minus I, just like right here. So there's also x equals negative 2i. So it seems that all of the solutions are imaginary numbers, but there are 4 solutions.